Hi, welcome back. We're studying the history of the meter. So in this short video, we're going to do the history of the meter and then start on the 7 base units and dimensions. So here we are, history of the meter. The meter over the years wasn't always defined the same way. So we have, in your particular notes, we have an early definition, a later definition, and then I'll share a little bit about how we currently define the meter and why is it that um, that the meter, the way that we define a meter has changed over the years. So here's the early definition. It was the length of a metal rod. And I'm noticing a typo right there. I don't need that comma there. I really probably just need a period at the end. So I'm going to just to kind of recall here. Anytime you see something in red, it's probably a note to myself that I need to make that change for the next year. This particular rod that they had had a name, and it was called the meter of archives. Now, if it was plausible, I would do a demonstration for you in video, but I really can't. But I'll try to describe it to you. If you had a long rod that was made of metal and you heat it up, that metal rod is going to change length. And if that metal rod was what you considered the meter, and that metal rod changed with temperature, then you have a standard that is dependent upon the air temperature, which could cause it to change. So you have a standard that's basically changing, which is not an advantage. So there are some disadvantages, other disadvantages as well. So I'll go through the first one. The first one is just the fact that its length changes. So we have a changing length. This Greek letter delta symbolizes change. So sometimes I'll use that as a way to signify change. Another one is if that 1 meter, which is called the meter of archives, if that 1 meter actually does get stolen, or if it breaks, then you're out of luck, and you have to come up with a new meter. So you have to reestablish it again. We want something that will never ever be destroyed. So it could be destroyed, or in the same vein, it could break. All right, and then another one. There's only one to make copies. So if you want to, for example, there's this metal rod and you wanted to make a meter, you would have to physically travel to wherever that metal rod is. If it was in France, you'd have to leave the United States, travel over to France, and take your metal rod and the official rod and cut yours off, I guess you could say, change the length of yours to match the length of the official meter of archives. And once you did once you made it approximately the same length, then you have roughly a meter. It won't be the exact meter, but it'll be close. And since there's only one of them on the Earth, the meter of archives, then every time you want an official meter or something that's as close as you can to the official meter, you always have to go to the location of wherever that meter of archives is located. That's kind of a pain in the neck. We don't want some physical object out there that we always have to compare against. We want another way of doing that. So they came up with another definition, and this is their next definition that they came up with. The later definition was they took a certain distance and divided it by 10 million. So 1/10 millionth the distance from the North Pole to the equator. And that's the way they changed that. So if you wanted to know what the official meter is, you measure that distance, which is not real easy to do, but I guess quite possible. Measure that distance, divide it by 10 million, and that's the meter. Well, that kind of worked for a while, but there were some drawbacks to that. So primary disadvantages. One disadvantage is difficult to measure that distance. Another problem is that the Earth's shape changes because of earthquakes. So every time there's an earthquake, that distance between the North Pole and the equator changes a little bit. And if that changes, then our meter changes. So they had to kind of go back to the drawing boards. An official rod didn't work because that changed with temperature. The distance between the North Pole and the equator changed a little bit, so that one didn't work. So they kind of came up with a different one. And this one they established in 1993, and it's the one that we currently use. And I guess before I give you this definition, I'm going to go ahead and describe something else to you. If you go all the way down to the size of an atom, atoms vibrate. And atoms vibrate at a very, very consistent, in a very, very consistent way that doesn't change really over time. So if you get a certain type of atom, or if you get maybe two of the same identical atoms, maybe like you know, helium or oxygen, get two helium atoms, they're both going to vibrate in the same manner, and you can use those vibrations to determine or make up or define what a meter is. And here's how they did it. So it's the length of the path traveled by light in a vacuum during an interval of 1/299,792,458th of a second. So basically, light, as an atom pulses, it also gives off light in a very regular way, and they watch that light travel. And as that light travels a certain amount of time, which is a very short period of time, that distance that light travels, we classify it as meter. There's a big advantage to this. If you can get yourself, actually I did screw up. Let me back this up a little bit. It has nothing to do with the way the atom pulses. I'm off on another tangent, so erase that thought. Let me clarify it real quick for you. Light travels at the same speed in a vacuum all the time. So if you take a flashlight, turn it on, that light travels at a certain speed. If we measure how long it travels, or how far it travels in a certain amount of time, then we can call that a meter. And so that's where we come up with the current definition of a meter. All right, what do we need to know before we actually define a meter? That is a second. So actually they have to define a second before they actually define a meter. And the whole vibrating of an atom had to do with the definition of a second and not the definition of a meter. All right, there are some definitions. It's reproducible. We can reproduce it very easily, so as long as you have a way of measuring light and how fast it travels and how far it travels in a certain amount of time, you can get yourself a meter. You really can't destroy it. It's a definition, and unless you totally wipe out the definition from the memory of everyone that's learned it, you can't destroy it. And so that's a really, really big advantage of defining a standard as opposed to giving it a physical object that might be out there. And the last one is that it does not change. That definition is going to be the same today, tomorrow, a month from now, a year from now, and so we don't have to worry about that definition changing like we had to worry about that particular meter changing. All right, one real quick caveat, and then we'll be done with this video. The word meter comes from the Greek word metron, meaning to measure. So when you hear the word meter, it just simply means to measure. And that's our video.